Hi there, welcome again. Today we are looking at matrices, determinant of 2 by 2 matrices. I think this is supposed to be part 5 of matrices. We've done the previous ones already, so if you've not checked that out, you have to go and check that out. You'll see it in our channel. Now before we start, I'll entreat you to subscribe to our channel. Just click the subscription button and then don't forget to also click on the notification button, so whenever we post any video, you'll be the first person to get it. And you can comment with all your questions, any questions that you have. And in case you have any problem, you can just call me on 0549-169-506, right? All right, so let's go. Let's set the ball rolling. Today we are looking at inverse of 2 by 2 matrix, okay? So as we said, supposing we have a matrix, if I have matrix A is equals A, B, C, D, then inverse of the matrix A is written as A. So when you see anything like this, it means A inverse, okay? Now the inverse of a matrix A is given by, the solution is given by 1 over the determinant of A, that's that of A, times, look at what we do, we interchange the leading diagonal, so D comes here and then A comes there, this comes here, this comes there, that's the leading diagonal, and then we negate the other two, so minus B and then minus C. This is how we find the inverse of a matrix. Now this particular portion, we call it the adjoint of the matrix, right? We call it the adjoint. So inverse of a particular matrix is given by 1 over determinant of that matrix times the adjoint of that particular matrix, right? Now a typical example, if I have the matrix M equals 2, 4, minus 3, 6, then if I want inverse of M is given by 1 over that of M. So we first have to find determinant of M, right? Now we all know that of M is given by what? The leading diagonal. So 2 minus 3, 4, 6. So this is actually given by the multiplication of the leading diagonal. 2 times 6, that's going to be 12. Minus 3 times minus 4 will give me minus 12. Of course, we all know that 12 negative will give me positive. So the determinant will give me 24. Is that also? Alright, so the inverse of this matrix is 1 over 24 times the adjoint of this matrix. And then the adjoint is given by what? As I said, interchange the leading diagonal, right? So 6 comes here and then 2 goes there. And then I negate this one. But remember, this is already negative. So when I negate it, it becomes what? Positive. And then I negate this 4 as well. Okay? Let's take another example, right? So if I have the matrix N equals 2, 4, 6, minus 7, then if I tell you to find the inverse of N, the inverse of N is given by what? 1 over the determinant of N times the adjoint of N, right? Times the adjoint. Is that also? So let's first find the determinant, right? Now we all know the determinant of N, that of N is given by multiplication of the leading diagonal. 2 times minus 7 will give me minus 14. Minus 4 times 6 is going to give me 24. So the final answer is going to give me 38, I think. Yes. Negative 38, sorry. So the inverse of N is given by 1 on negative 38 times the adjoint, that is interchanging the leading diagonal. Next 7 goes here, 2 comes there, and then I negate these 2, right? Now this is my inverse, right? You can choose to expand if you want to expand. So if you are expanding, which means that this is going to be 6 on 24, minus 4 on 24, and then this is going to be 3 on 24, and then 2 on 24, right? You can simplify it if you want to, but you can also give it like this. Nobody is going to penalize you for that, right? Now, if it's in core mathematics, then I'll entreat you to simplify it to the lower. But in elective mathematics, this thing is not actually problem, so you can leave it this way. So you can also leave this one this way as well. Or if you want to simplify, 1/38 multiplies every component here. So it becomes, this multiplying this will be -7/38. And then this one becomes -4/38. Now this one becomes -6/38. And then this one becomes 2/38. You simplify that and then you put your answer there. Alright? Okay, now there are some few things I want you to note. That number one, if a matrix has no inverse, then the determinant of that matrix is equal to 0. Of course, you can clearly see it here because inverse is 1/determinant times adjoint. So if determinant is 0, it means the matrix will have no inverse, because 0 times any number becomes what? In fact, it's even undefined. It's even undefined. You get that? So if a matrix has no inverse, it means the determinant is equal to what? 0. Okay? So I want you to note that. And also note that whenever a matrix, if M is a matrix, then if M is multiplied by its inverse, this one gives you an identity matrix, right? So where I is an identity matrix. Okay? And remember we said identity matrix when we were starting, we said it's 1 0 0 1. Whenever a matrix multiplies its inverse, you get an identity matrix. Let's just prove this to see whether what we are saying is true, and then we will come to a close on this episode. So let me take a matrix. Let's just use this one. So if I have a matrix and that is 2, 4, 6, -7, right? And then I'm supposed to I'm checking if when the matrix is multiplied by its own inverse, you are indeed going to get 1 0 0 1, right? Alright, so we've already found the inverse of the matrix. The inverse of the matrix gave us this, right? So let's multiply n with its inverse. Now I have the matrix n to be 2, 4, 6, -7. Now multiplying, you know, this one is the same as n inverse times what? N. It's better to do it this way because of this particular fraction there. Okay, so let's rather do it this way. Let's bring the inverse first. So 1 over -38. The inverse is -7, -4, -6, and then 2. Now multiplying the inverse, that is 2, 4, 6, and then -7. So let's first expand this, multiply this. You know, it's -7 times 2, that's going to be -14. And then plus -4 times 6, that's going to be -24, right? And then the same thing goes here. 7 times 4, that's going to give me -28. That's -7 times 4. And then -4 times -7 is going to give me -4 times -7 is going to give me +28. Is that also? All right, and then let's go. Now we take this one. -6 times -2 is going to give me -12. And then 2 times 6 is going to give me 12. Is that also? And then -6 times -4 is going to give me -24. And then 2 times 7 is going to give me -14. right? All right, so you realize that now if I have negative 14 plus negative 24 is going to give me negative 38, right? Now this is going to give me 0, this is going to give me 0, and then this is going to give me negative 38. Is that not so? Alright, now if I expand this one, do you realize this one gives me negative 38 over negative 38? And then of course this is 0 over negative 38. That will give me 0. This will give me 0. Now this will also give me 0. And then this one will give me negative 38 on negative 38. Do you realize that neg 38 on neg 38 will give me 1? This of course 0. This is 0. And then this will also give me 1. So that confirms that whenever a matrix is multiplied by its inverse, you get an identity matrix. That is 1, 0, 0, 1. Alright, so this is where we'll end this on this episode. Now after teaching everything, the last episode will be solving of advanced questions, which we will solve a lot of advanced questions on this particular areas. Right, so this is where we'll end on this episode. So see you on the next episode, where we are going to study how to use inverse and determinant to solve simultaneous equation. So until we meet next time, I'll say goodbye for now.